let's go through question number 18 on the topic of mole concept. Okay, VS paper 2020, paper 1. So right now, take a look. You have about 300 cm cube of oxygen gas, of which only 10% was converted. So in this instance, right, so I take 300 cm cube times 10% first, which means it's 30 cm cube. So 30 cm cube is here. And over here, right, 30 cm cube, it was converted. So if this 30, this will be 20 cm cube, because if 3 parts represent 30, 2 parts represent 20. I can only use this concept if and only if my reactant and product are all in gaseous state. All right. So at the start, okay, at the start I have 300, of which 30 is used up. Okay, so I'm left with 270 remaining. All right, this is the remaining. But at the end of the day, the product that is formed, right, is 20 plus 20, right? You get 290 cm cube. Answer is C. Okay, answer is C. All right. Then some of you, right, might even ask, hey, can I actually use the mole concept method? Okay, whereby I take from 30, right? Okay, divide 24,000. Let me show you this way. Okay, the way that I've just shown you is actually a shortcut. Okay, so if you divide 24,000, right? Yes, you can. Then you need to divide by 3. Why? Because you need to find one part, ma. Okay, this for 3 parts, right? You divide by 3 times 1/3. Then it is a mole ratio of 3:2, so you need to times 2. Okay, then if you were to convert it back to gas again, right? Okay, you need to times 24,000 cm cube. Can you see that actually this and this will cancel off? That's why when I mentioned that the shortcut can only be used if and only if this is a gas and the reactant is a gas and the product is a gas. So 18 option is C.